Hello there again. In this video we're going to talk about the most unique feature of Rust, ownership. To understand ownership, you first need to understand what is the problem that ownership tries to solve. Ownership appears as a solution for memory management. I'm simplifying here, but before Rust there was two ways of handling memory. Automatic memory management, usually with a garbage collector. This is what Java, Python, Go, and many more others do. And manual memory management, this is what C and C++ do. In this case, programmers have complete responsibility over when the memory is allocated and free. Historically, this has led to a lot of memory bugs and vulnerabilities. It's hard to keep track of memory allocated and to decide when to free it. But there is situations when programs cannot afford to waste time in garbage collector cycles. That is why C and C++ are preferred in situations when performance matters, like games, operating systems, really demanding physics engines, etc. Rust brings a third option. With ownership, the programmer is freed from the burden of allocating and freeing memory manually without the need of a garbage collector. To do this though, you have to learn to deal with the rules imposed by the Rust compiler. But don't worry too much about it, you're gonna learn how to deal with them step by step in the book. In chapter 4 of the Rust book, you're gonna learn about ownership and the different regions of memory and how to deal with references. Take your time to understand this concept. Understanding memory management is one of the most difficult things in the language, and it's the basis of a lot of what comes after, like lifetimes. Now I want to give you a few questions that you should be able to answer after finishing reading the chapter 4. So these questions are: what is ownership? What is the heap? What is the stack? What are the differences between the two of them? What are the ownership rules? What is a reference? And what is the relationship with borrowing? What are the rules of the references? Why do we need rules for references? And what is a slide? And why are they useful? And now I'm gonna answer a few of those questions for you. I want to show you the ownership rules and a bit example of them. So the first rule of ownership is each value in Rust has a variable that's called its owner. So in this code, which you can see, when we declare a variable, we're saying in this case that X is the owner of this string. And of course, we can use them as you would expect. The second rule is there can be only one owner at a time. So in this case, X is the owner of the string. Then when we assign Y to X, we're giving ownership of the string to Y. So if we try to print Y and then print X, we have a compiler error. We see that the value of X was moved to Y. So we have no longer access to X because X lost the ownership of the value. And the third one is when the owner goes out of scope, the value will be dropped. So in this case, we declare a block which reduces the scope of this variable. So in this case, Y doesn't exist after this section of code. So that's why we cannot access it, and that's what the compiler tells us. Now let's take a look to the reference rules. The first rule is at any time you can have either one mutable reference or any number of immutable references. So to start, we declare a variable called X, defined as a string, and we define three immutable references to X. If we try to run this code, we can read the value of X and the three references. because we're not breaking this rule. But what happens if we declare immutable references here? If I make ref1 a mutable reference, then we have a problem. We cannot borrow mutably since we are borrowing immutably at the same time. A workaround that we could make is to modify the string before creating a new immutable reference. And to do that, we also have to remove our usage of the immutable reference encode after this. So if we delete this, now this should be okay. So what is happening here? Since we are declaring an immutable reference and we're using it just until this line, Rust is smart enough to know that they are not happening at the same time, and this reference is not longer valid at this moment. So you can mutate the string and then create a immutable reference to the value. And as we can see, the value was mutated. In the beginning, it was the text was a string, and after is a string with a exclamation point at the end. Let's go to the next one. References must always be valid. So in this example, we have two things happening. First, we create a local variable, which is a reference to a string, and then we try to return it to a variable in the outside scope and to print it. This is not valid for two reasons. So by the ownership rules, a value is dropped at the end of its scope. So in this case, x is gonna be dropped here. So this value no longer exists, and therefore a reference to it will be invalid. To go around this, you have to create the reference in the same scope. So if we change this way, now this code is valid and it will work like we expect. That's it for this video. See you in the next one. Bye bye.